We talked about how to find lengths of different parts of the chords when intersected by a perpendicular diameter. But what happens if it's not a perpendicular intersecting chord or line? Well, let's think about what we do know, okay? If we create a triangle by connecting two of our points of the intersecting chords, we create similar triangles. Well, how do we know they're similar? Let's stop and think about what we know. We learned back in Theorem 10.6 that if we have two intersecting arcs, or inscribed angles, as we do here, then that means that our angles are going to be congruent. We also know that these two angles are going to be congruent. Therefore, by our triangle similarity of angle, we know that our two triangles are similar. And so that tells us, or brings us to Theorem 10.15, that if two chords intersect in a circle, then the products of the measures of the segments of the two chords are equal. For instance, AE times EB is going to be equal to CE is equal to ED. Therefore, if we have, for example, a circle with these measurements on our chords, we can use that theorem and say that if AE is X, EB is 6, CE is 3, and ED is 4, we can say 6X is equal to 12, and therefore X is going to equal 2. These relationships continue even if we have two secant lines. For instance, Theorem 10.16 tells us that if two secants are drawn to a circle from an exterior point, then the product of the measures of one secant segment and the external secant is equal to the product of the measures of the other secant segment and its external secant segment. So what does that all mean? It means that we can take the product of the entire distance of the secant line times the measure of the external secant, and that is going to be equal to the entire measure of the other secant segment and times the outside secant segment. Okay, so let's find the value of X. Now our theorem tells us that if we take the entire length of the secant, so that would be 3 plus X, and multiply it by the external secant, that's going to be equal to the other secant's total value, which in this case is going to be 14, times the outside value of 2. So when we distribute, we're going to get 3x plus x squared is equal to 28. Well, how do I go about solving for x? Well, let's set it to 0 and find the roots. So when I subtract 28, I'm going to get an equation of x squared plus 3x minus 28 is equal to 0. Well, let's think about how we want to factor that. What values or products of 28 are going to give me a positive of 3? So let's think about the factors of 28. We have 2 and 14. Well, that's not going to give me 3. But then we have, how about 4 and 7? That's going to give me a value of 3 because 7 minus 4 is equal to 3. So I can factor my quadratic into an equation of x minus 4 times x plus 7 is equal to 0. Now, let's think about solving for x. That means I have x minus 4 equal to 0 and x plus 7 is equal to 0. Well, when I solve for x, I add 4 to each side, and so x is equal to 4, and I subtract 7 from each side, and so x is equal to, negative 7. Now, we're looking for a distance and a measure. So can we have a negative value? No. That means that the value of our distance of the outside secant is 4. Which leads us to our last theorem of this section that says that if a tangent segment and the secant segment are drawn to a circle from an exterior point, then the square of the measure of the tangent segment is equal to the product of the measures of the secant segment and its external. So in other words, if we square AB, that's going to be equal to the product of the whole secant measure times the outside of the secant measure. So let's take a look at an example. Here we have our tangent line having a measurement of 4, and so we can have 4 times 4, or 4 squared, is going to be equal to the measure of our entire secant line. So we're going to have 2x plus 2, because I got 2 x's, times this outside measure of our secant, which is x. So when we distribute, we're going to get 16 is equal to 2x squared plus 2x. Okay, again, let's set it to 0. So we're going to have 2x squared plus 2x minus 16. Well, when we start looking at our different factors, I notice that all my numbers are even. So I can pull out or factor out a 2 and or divide everything by 2, however you want to talk about it. And I'm left with x squared plus x minus 8. So let's work on factoring that. We have x squared plus x minus 8. All right, my factors of 8 are going to be 1 and 8. That's not going to give me a product of 1. I have 2 and 4. That's not going to give me. So therefore, this one's not going to be factorable. So I have to use the quadratic formula. Remember, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So when we look at our equation, we have that a is equal to 1, b is equal to 1, and c is equal to negative 8. So when we plug and chug into our formula, we have that x is going to be equal to negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 8 all over 2 times 1. And when we simplify that down, we get that x is going to be equal to approximately 2.37.